Welcome back guys on India's largest e-learning platform, that is BYJU'S Exam Prep. So guys, this is the second session of production, that is the practice session. And we have already seen many other subjects before in this HAL and BARC series. So guys, today we are having the second session of production. And guys, quickly like and share the session so that others can also join the session. And today we are going to cover the topics which are, first of all, the metal cutting, which is very important, you know that. And other than metal cutting, we are going to cover metrology. Okay. And after metrology also we have questions from computer integrated manufacturing and also about the material size. Okay. So we are covering these four topics today because all other topics we have covered. Yes, sheet metal operations also. Okay. Because metal forming, bulk metal forming we have seen, but sheet metal operations were left. So guys, we are having questions on these topics today. Okay guys, so I feel you guys are ready for that. Shall we start the session? Yes, please comment in the comment section, like, share the session also. So guys, this is some detail about me. This is about some experience of teaching in this field of GATE and ESC. These are my areas of expertise, that is strength of material, theory of machines, machine design, industrial engineering and production technology. And in ESC paper 1 I take basics of project management and material science. Rohan, hello dear. So let us continue the session. So guys, now BYJU'S Exam Prep is a complete solution for your GATE and ESC preparation. Not only GATE and ESC but also the exam like BARC, HAL, HPCL, all PSUs and state PSCs. So my dear, Saikat, good evening dear. So now we are starting the session. The very first question from metal cutting part is in front of you. Here cutting velocity is mentioned as V, and phi is the shear angle, alpha is the rake angle, and they are asking you the chip velocity. Yes, you need to answer this. Definitely dear Rohan, actually BYJU'S will provide you post-gate guidance in the terms of many sessions on YouTube also. So dear, just as your results are coming, after that you would be having a number of sessions, and also you can get the personal guidance also from the faculties as you have been a student, and even you can discuss your score with me. I will also personally guide you for that if you want. Okay. So definitely you can see the sessions just after your results. Many sessions would be there. Ankit Tripathi, good afternoon dear. Yes. So dear, this is the first question. V is the cutting velocity. You know very well, when we have interfaces, this is workpiece. We have actually 3 interfaces. We are also having a cutting tool. I am showing it with different color. And then my dear, we are having the chip like this. So this velocity is said to be chip flow velocity, and this velocity is said to be the cutting velocity, and this velocity is said to be the shear velocity. You know that this angle is phi. This angle is alpha. So there is a relation between these 3 velocity. Cutting velocity is denoted by V. So I will show it with V. So this is the cutting velocity, V. This is the chip flow velocity, VF. And this is the shear velocity. So this is how the triangle is being formed. And if you see this, you must understand that whenever we are going to talk about these 3 velocity, this triangle is said to be the velocity triangle. And by applying the sine rule in this velocity triangle, we can find out the chip velocity. Yes, Gaurav Vajpayee, wonderful dear. Answer is A from Ankit, from Gaurav, from Rohan and from Saikat. And guys, as all of you have given that yes, answer A is correct one. So today we are having a number of problems on different topics. So the answer is coming out to be A, that is V sin pi by cos phi minus alpha. So you will say some people are showing it as VF chip flow velocity, and this is V sin phi divided by cos phi minus alpha. So using this formula, you can find out VF if V is known to us. Using sine rule, you can find out VS, VF, V the relation between all of three. Okay, so let us see the next question, guys. We are moving to the second one, and the second question is this. This is from Taylor to life equation. My dear, previous question and this question, they are more of HAL and BARC, HAL type more, because in BARC generally questions are of gate level, so more chances of first two question are for HAL. Don't worry, I am having the questions suitable for both the exams. Very good, guys, wonderful. So this is using Taylor two life equation, VTN is equals to constant. So we are talking about Taylor two life, not modified one. Calculate the percentage increase in the tool life when the cutting speed is reduced by 50%. So my dear, when velocity is becoming V by 2, N and C are given to you, you need to find out the the increase in tool life if velocity is reduced to 50%. So let us say T1 is tool life first and it is changing to T2. So you need to find out T2 minus T1 by T1 into 100. This is what you need to find out. The answer would be coming in percentage. Aspirant, don't be panic about this. I would like to say sometimes things take time. Okay, for everybody things are not going to be very easy for the first time. So if you would be demotivated like that, it is going to be very difficult. So dear, there are many opportunities in the market. You need to see which one is going to be suitable for you. So if you are getting nearby marks from last 2 years, then you shall try once more. But if you are getting less marks and you are thinking to go for some other exams of similar manner or somehow lower manner like SSC JEE, SSC CGL, you can try for that also. That depends at which level you exist right now. Okay, so Gaurav is saying A, Ankit Tripathi is saying A, Rohan is also saying A. Let us see. So my dear, you know the equation, Vt to the power n is equals to constant. You know C is a constant, Taylor to life constant, so we can write V1 T1 to the power n, V2 T2 to the power n. So my dear, you know V2 is V1 by 2 because speed is getting reduced to half. So when you would be putting this value, my dear, you would be getting V1 T1 n is equals to, it is V1 by 2 into T2 to the power n. So my dear, V1 will get cancelled out. So you would be getting T2 by T1 to the power n is equals to 2. N is 0.5. So 0.5 when you would be putting, you are going to square it, you will get T2 as 4 times T1. So tool life becomes 4 times. So when you would be finding out the answer, 4 T1 minus T1 by T1 into 100. The answer is 300%. A is the answer for this. Very good. Gate marks less, sir, that's the problem. 65 to 68. Aspirant, 65 to 68 is not a bad score, I will say. Are you from mechanical or civil? That also please specify, because I am confused into that. Are you from mechanical or civil? Question number 3, guys. Once again from Taylor to life. Don't worry, we have covered all the topics. Very good, Saikat. So this question is in the Taylor to life equation, Vtn is equals to constant. The value of n is 0.5. C is 180 minutes at a cutting speed of 18 meter per minute. Tool life is reduced to 45 minutes. Then the cutting speed will be. So once again, you need to apply the similar equation. You will get the answer. Okay, so aspirant, as I said, as you are from civil engineering, 65 to 68 is not a bad score. I will say it is a very good one. Yes, no doubt, chances of PSUs are very, very less. But still, dear, I will say you can easily get IITs or NITs, and I will suggest you to go for MTech program at some of the IIT, okay, or at some of the NIT, good NIT, old NIT. So in that way, you would be getting once again the chance to prepare during your MTech, and also you will get some good job from IITs if you are going for MTech, okay. And obviously chances would be there for preparation also, because you are not new to the preparation. You need not to go for full day preparation. You need some day for regular work. So dear, this is my suggestion. Rest definitely after GATE exam. All the civil faculties at BYJU also will be taking the sessions. You can directly interact with them. They will give you some very good advices. Okay. So, but whatever I said, it's a good one for you also. So dear, when we are talking about this, many students are saying answer to be C. Ankit Tripathi, Gaurav and Rohan, and dear, answer is correct. C is correct. So you would be doing in the same manner V1 T1 to the power n, V2 T2 to the power n. Dear, actually for some students, sometimes things take time. Okay, so don't be panic. This is 18. Tool life is 180 minutes. You can see among you only, you have seen Parvinder, he got selected. In GATE also he is getting very good marks. So my dear, likewise, you can also do. For that, sometime you need to wait. V2 is 180 by 45 to the power n. 180 by 45. Yes. So you would be getting V2 to be 36 meter per minute. N is 0.5, 45 will get cancel out this 4. N is 0.5 will give it to be 2. So answer is C for that. Next question, guys. Next question is, in an orthogonal cutting process, rake angle is 20 degree. So alpha is given as 20 degree to you. Then friction angle, beta is also given 25.5 degree. Using Merchant's shear angle relation, the value of shear angle will be, yes, use Merchant's relation and find out the value. Yes. Is it the relation? Is this the relation? So you just need to find out the values of beta and alpha and you would be getting the answer. Yes or no? Okay, Gaurav have given answer to be B. Ankit Tripathi have given the answer to be B. Okay, what about others? Rohan is also saying B. Okay, so dear, answer is B. Yes, it is correct. So you would be writing pi by 4 is 45 degree minus beta is 25.5 by 2 plus 20 by 2. So answer would be 42.25. Answer is B for that. Okay, guys. So if you would do some mistake, you will put plus here and minus here. You would get C. So that is why they have made the options like this, to make you confuse. Very good, Saikat. Let us move to question number 5 now. So guys, today we have in a total 22 questions. Okay, and this is from which topic? Grinding. So this question is from grinding. Designation of grinding wheel. Designation of grinding wheel. This type of question you can have in HAL and BARC both. In GATE also this type of question have been there for many times. So just try to solve it, guys. Just try to solve it. Which one of the following code is correct? Aluminium oxide abrasive, medium grain size, open structure and rubber bond. Okay, so I feel in all the cases the letters are same. You need to see the correct digits. So when it is saying open structure, it is close to what? You know, when I taught to you 0 and 16 were the number. 16 were for the completely open structure. 0 was for completely closed. So you need to select out of 10 and 7 which one is more close to the open structure, which one is more near to the open structure. So one selection is this, other selection is based upon the medium grain size. So this number will be giving you about medium grain size, small or medium grain size. Okay. So dear, yes, Ankit have given the answer to be C, Gaurav D, Saikat D. The answer is D. Because my dear, 10 is more near to the 16. So it will give you the open structure. And 0 to 8 is coming for closed structure. 8 to 16 is coming from open structure. So because of this and this, 30 will be giving you the medium grain size. So D is going to be the answer. Very good, guys. Wonderful, wonderful. Let us see the next question. Question number 6. My dear, this is from actually metrology part, not metrology, inspection part, where they have given you the maximum surface roughness and they're asking about the average surface roughness. Yes, it is a NAT, but in paper you will be getting it in the form of MCQ only. Okay, so just solve it. Just solve it, and tomorrow we have the session related to machine design. Now 2 sessions, Monday and Wednesday, will be from machine design. Okay. Solve it, guys. Solve it. Rohan is saying 8. Ankit is saying 8. Very good. What about others? So center line average is equals to maximum surface roughness which is peak to valley height divided by 4. It is defined as H max by 4. H max is 32 divided by 4. 8 is the answer. Answer is not mm, it is micrometer. Very good. So Ankit, 8 microns, because the answer is asked in this way only. Very good, guys. Question number 7 in front of you. So this question is from computer integrated manufacturing. This is from G codes. This is from G codes. So computer integrated manufacturing. This is from G codes. You have studied about G codes and M codes. So the same is the question about. Yes. Yes, yes, yes. So we have seen some codes. Let us see G00. Let us see some famous codes. G00 is used for point to point positioning. This is used for that. Okay. We have seen some other code as G01 is for linear programming. Sorry, is for linear interpolation. Do you remember it? So G01 is for linear interpolation. R is with 1. You can see R is with 1 only for C and D. So either your answer would be C or your answer would be D. Is it clear? Then we know that G02 is for circular interpolation. That is clockwise. G03 is for circular interpolation, anti-clockwise. So these are some famous code which I told you always to remember. Okay. G04 is used for dwell. Is it clear or not? And my dear, similarly, when we are talking about G05, It is used for hold. Yes or no? And my dear, when we are talking about this, so the answer for this would be, if you're talking about G21, G41 also, so the answer for this question would be what? This way I have discussed many G and M codes with you guys. So Rohan have given the answer say, Ankit Tripathi have given the answer C. So the answer, Saikat have given the answer as D. I would like to say the answer is going to be C for this. So dear, this is how we are going to deal with this type of question. I have given a list of G and M codes to you, and if you want that list which you need to remember, I will be sharing that with you. Okay, so this is how we can solve it. Let us move further. Next question is again from G codes and M code. Here they are asking only about these four codes: G01, G33, G03 and G04. So let us see how many give the right answer for this. You can take help from this previous one. G00, G01, G02. So likewise, there is a table where I have shared around 20 to 22 codes with you. And every time questions are coming from those 20 to 22 codes only. Okay. Dear, actually Rohan, in the previous case, that G08, that is actually when you are going to match, others are matching, G08 is not matching with that, because if you see this is coming with 3. Okay, so circular interpolation is not for G08, but for all others, if we see, G41 is going to be cutter radius compensation, okay, and G21 is going to be for acceleration. So in that way we can take it C only. Okay, so this is by mistake, you can say. Sometime options are having that kind of mistake, so we need to take care of that. Okay, is it clear? So here what is the answer? In engineering services also it happens. We need to go for most appropriate. Ankit Tripathi saying C, Gaurav Vajpayee C, Rohan is also saying C. Yes, C is correct. You can see G01 is for P2P. No, this is for G00 actually. So G00, not G01. G00 was for absolute positioning. Now we will be saying G01 is going to be for linear countering या फिर linear interpolation. G33 is used for thread cutting mode, and G03 is for anti-clockwise circular interpolation, and G04 is used for dwell. Okay, so based on that we will be getting the answer to be C. Let us move to the next one. This is once again the question is from CIM. As I told you, I have covered all the topics, so that from where the question is coming you must be in a position to do. So Rohan is saying C, Saikat is saying C for previous one, it's correct. What about this machine center? What is machine center? An automatic tool changing unit, a group of automatic machine tools, a next logical step beyond NC machine, an NC machine tool. Yes. Yes, guys. Question number 9 it is. Guys, quickly like and share the session. Ankit is saying B. What about others? Rohan is saying B. थोड़ा सा याद कर लो डियर, मशीन सेंटर क्या होता है और टूल जिसमें होते हैं उसको क्या बोलते हैं. You are getting confused between two things. There is one thing known as machine center, other is tool magazine. So you are confused between the two. Okay? शायद इस हिंट के बाद आप लोग सही आंसर कर दें. Something called as machine center. Second thing is Gururaj, when it would be starting, you would be getting notification on the BYJU'S Exam Prep YouTube channel also. Saikat is having B, Rajarshi Mondal is getting A. So dear, yes, A is correct, because when we are talking about machine center, second thing is tool magazine. Tool magazine is something which consists of various tools. So machine center is where we are going to use them. Okay. Yes, I feel Rohan have answered you. So answer would be A for this. Great. Second question is, this time the question is from non-traditional machining methods, or you can say it is non-conventional machining method. This is a numerical from electrochemical machining, ECM numerical. So it is given as in an electrochemical machining operation, a square hole of dimensions 7 cross 7 is drilled in a block of aluminium. The current used is 6000 amperes. 6000. The atomic weight is 27. Valency is 1. Faraday constant is 96,500 coulombs. You need to find out the MRR in gram per second. We have seen many formulas to find out the MRR. Very good, Rohan. What is the answer for this? What is the answer for this? This is atomic weight into current Z into Faraday constant. Z is electrochemical equivalent. Yes. Sorry. After putting only we are getting it. Z is valency here. Here it would be valency. Find out the answer. Answer is required in gram per second. Okay, Gaurav Vajpayee have done it. He is getting 1.678 gram per second. Okay, what about others? Formula is in front of you. Atomic weight is 27. Current is 6000 divided by valency is 1, 96,500. Very good. King Suk, Ankit Tripathi, Omkar, all is well. Rohan, everybody is getting the same 1.678. So dear, when you are practicing here, you are getting the similar question which you are going to get in the exam. This is really going to help you in the exam. Dear, actually, you can see it is coming 1.67 gram. So if you would be taking it in kilogram, you can feel how difficult it would be to describe. So that's why whenever we are talking about ECM, we are giving the answer in this way only. Yes. In turning tail, using orthogonal cutting, a chip length of 8444 was obtained for uncut chip length of 200 mm. Yes. Solve it, guys. Solve it, guys. Solve it. Actually, this is 84 mm. In turning trail using orthogonal cutting, a chip length. So LC is 84 mm. And uncut is 100 mm. The cutting conditions, you can see the velocities are given. Uncut chip thickness is 0.5 mm, rake angle is 20 degree, width of cut is 2 mm, cutting force is 900 Newton, and cutting tool is high speed steel. The coefficient of friction if the machining is taking place under Lee-Schaffer shear angle conditions. Okay, so you need to apply Lee and Schaffer theory for that. So phi plus beta minus alpha is 45 degree. That is Lee and Schaffer theory. Lee and Schaeffer theory. So my dear, first of all, you need to find out the phi, that is tangent inverse r cos alpha 1 minus r sin alpha. Apply this and find out the phi first. Okay, once you get the phi, you will get the beta. Once you get the beta, tangent beta is your answer. Hint is there. I am always doing the hint in front of you on the board, so that if you don't know how to solve, then also you get the idea to solve it. Okay, Gaurav have already answered it as C, 0.847. Okay, what about others? Omkar is saying 0.847. Very good. Very good, very good. Okay, Gaurav is saying phi to be 24.74. Let me check. Very good. So you are getting phi 24.74. That is correct. Putting the phi value here, you will be getting the beta value. Beta value you will be getting as 40.26. Putting this value here, you would be getting the mu value to be 0.847. Because you know tangent 45 is 1. Very good. Rohan, Saikat, very good. So guys, this was 11 question. As this is a common data, actually nowadays common data are not coming in the paper. But still we can solve it as a question. So that's why the same data, 84 mm. This time you need to answer about shear stress. Okay. So the second part of the question is asking you the shear stress. You already know shear stress is given as shear force by shear area. Shear area is B into T1 by sin phi. T1 is uncut chip thickness. Fs is shear force. So this is the formula you need to use to find out the shear stresses. And to find out Fs, you need to apply Fs is Fc by cos beta minus alpha into cos phi plus beta minus alpha. This is coming from merchant circle relations. You remember it. I have given you the relation between all the forces in that. So applying this formula, you will be getting Fs. Putting this here, you will get the tau s. Okay, solve it and get the answer. Cutting force is given as 900 newtons. This is a good one, a good question. So guys, you can also share your marks with me either on Telegram or WhatsApp. I would personally suggest you what would be the best option for you. Okay, Gaurav, Saikat, Rohan, whatever you are getting, Omkar, all is well, King Sukh, whatever you are getting in GATE, do share it with me on the WhatsApp and I will guide you accordingly what would be the best option for you. Okay, Gaurav is saying A as the answer. So dear, very good. The answer you are getting is absolutely correct. Very good, Rohan. So Gaurav and Rohan, you are getting the right answer. Fine. So dear, first when you would be putting the value of phi, beta, alpha, you would be getting shear force. Shear force would be coming out to be 678.35 newtons. Okay, now you need to find out the shear area and put the value. When you would be finding out the shear area, so I don't have the calculation for shear area, I have directly put it the value and you would be getting 284 MPa. A is the answer. Okay, very good Omkar, very good Saikat. So we are moving to question number 13 now. 12 questions we have completed. Very good. So we are going nicely. This is the 13th question. Here also shear force is being asked. This time they have given us cutting force and thrust force. Shear angle is also given as 60 degree. So what is the approximate value of shear force? Yes. FC cos phi minus FT sin phi. Apply the formula, solve it. Yes, guys. Very good, very good. Rohan, wonderful. So cutting force is 600 cos 60 minus 173 sin 60. 150 Newton. Very good. Gaurav, Saikat, Omkar, Rohan, बहुत बढ़िया. Let us see question number 14 now. This is the question from milling. Question from milling. This time I would give you the hint. This is the formula for maximum chip thickness. 2 times Ft square root of D by capital D. So you can see T is directly proportional to small d by capital D. So it is mentioned that during the conventional milling operation, if depth of cut gets doubled. So dear, you would be saying T1 by T2, solving it. For T1, you know that D is becoming D by 2. So what is the effect of that? They are asking it in terms of percentage. So you can find out as T2 minus T1 by T1 into 100. That is what you need to find out. First of all, from here you would be getting T2 in terms of T1. Okay, Gaurav is saying C, Omkar is saying C. Ankit Tripathi is also saying C. Very good. So dear, you can see actually T is directly proportional to small d by capital D. And you can see capital D is constant, only small d is changing. So it is nothing but square root of D and D by 2. Okay, because T is directly proportional to square root of D. So when you would be having this, is it clear? Yes. So from that you would be getting T2 in terms of T1. So after getting this, you would be putting the value and you will be getting the answer. Okay. Okay. Capital D is also going half. Sorry. Actually, small d is going 2 times. Capital D is going 1 by 2. Okay, sorry. Then both of them you need to write. D by capital D. It is 2D by D by 2. So you would be getting T2 as 2 times T1 and putting this you would get the answer as C. Is it clear now? So I have not seen the complete, that's why, but now it is fine. You need to take the both effects because it is mentioned that small d is doubled whereas cutter diameter reduces to half. So you need to consider both of them. Question number 15, guys. During grinding of a cast iron specimen of 10 mm wide and 100 mm long, This is the grinding wheel specification given. 300 mm is the dia, 25 mm is the width. The wheel has undergone a radial wheel wear of 50 microns after removing a layer of 5 mm. You need to find out the grinding ratio, guys. So guys, we reached to 15 questions, but still 7 questions are left. Okay. So just like and share the session so that other students can also reach. The best thing is I have considered each and every part. I have considered question from CIM, from metrology, from non-conventional machining, from machining operations, everything. Yes. So solve it. First of all, find out the volume of grinding wheel wear. It is mentioned already that grinding wheel of 300 mm diameter and 25 mm wide, the wheel has undergone a radial wear of 50 microns after removing a layer of 5 mm. Okay, so you can find out this pi by 4 di square minus df square, as it is mentioned that the radial wear is there, and then you would be finding out volume of workpiece removal. So that is length into width into depth. It is mentioned that we have went through 5 mm. Depth is given. Length and width are mentioned. And you know grinding ratio is, this is V2, this is V1. V2 by V1. Solve it, guys. Omkar is getting 2.12. What about others? Tell me what you are getting here and here. Very good. So now Omkar have changed the answer. He is saying 4.24. Great. What about others, guys? Wonderful. So guys, you are going to get 1177.9 mm cube here, and the second portion you are getting as 5000 mm cube. So only Omkar have given the right answer for this. The answer is D. You would be getting it. .24 is the answer. Very good, guys. So answer is going to be D for sure. Question number 16. This is from sheet metal operation now, because yesterday we have not covered sheet metal operation. So this is from sheet metal operation. Yes, guys. Rajarshi, I feel for that a session have already been taken, where everything about that, the marks and how you need to solve, how Kelsey work would be done, everything that we have discussed in the session, I feel. Yes. The minimum dia of hole. Yes, guys. I feel many of you have attended those sessions. Can anyone answer Rajarshi for that? Anyone? Rohan? We have put in a general session there for that. Generic session. And even in a short also I have discussed about all those things. Don't worry. Okay, 16 you are getting, Rohan you are getting D. So Omkar is getting A. Okay, Rajarshi. So I actually wanted to check how many of you have attended the session. Okay, that's why I said that any student would be answering. So the minimum diameter of hole which can be produced on the sheet of 4 mm thickness, having shear strength of 400 MPa, crushing yield strength of 1600 MPa. So my dear, it is mentioned that the factor of safety is 2. Factor of safety is mentioned for that. Okay. So my dear, when factor of safety is already mentioned, first of all, this is for the punch you are having 1600 MPa. So when you would be using the factor of safety, it would become sigma allowable is sigma failure upon n. So this is going to be 1600 divided by 2. It is 800. Okay. So my dear, you know, we need to find out the minimum thickness. That is 4 tau by sigma allowable. Is it the formula? Is it the formula? Yes, 4 times it is what? You need to find out minimum dia. So when you want to find out the minimum diameter, it is 4 times tau into thickness divided by sigma allowable. So 4 times tau into thickness divided by sigma allowable. Thickness is 4 mm. Divided by allowable is 800. So this is 4 cross 4 into 400 MPa. This is 800. So you would be getting 8 mm. Is it correct? B is the answer for that. Because this factor of safety is given for this only. Mind it. So B is going to be the answer. Is it clear? Saikat, very good. Omkar, you got your mistake because it is mentioned now that crushing yield strength is 16 MPa and a factor of safety of 2. So that is why the answer would be 8 mm for this. Great. So let us dear, but as I said, what you are saying is not for that. 0.032 is to find out the that is used for the optimum conditions. Here they are asking about the minimum diameter of hole. This is a separate topic in the metal forming. Okay, so this is a separate topic of metal forming. What you are saying is that is used for the clearance purpose. That is not even the formula what you are saying. That is used for optimum condition where you are going to have the optimum conditions, and that is used where we are talking about clearance and all. I got which formula you are talking, but this is not the same. This is actually what happened is when you are talking about the punch. So when punch is going to fail the sheet, then punch is going to apply some force onto the sheet that you already know, that shear force is tau into pi dt. And the same force as a reaction, sheet would be applying onto the punch. So sheet will also try to fail the punch. So when sheet would be applying the same force onto the punch at the contact area, punch was applying it in the form of shear force, but sheet is applying in the form of compressive force. So the magnitude is same, direction is opposite. And my dear, this tool, this punch will be giving resistance in terms of the sigma compressive strength into pi by 4 d ka square. So when you would be equating these two values, then you would be getting the minimum diameter hole which you can produce from this. Got it or not? So you need to equate these two things. Actually, this is trying to fail the punch and this is trying to save the punch. This is the strength of punch. This is the force coming on the punch. When you would be equating them, you would be getting the diameter. That is the minimum diameter. Why? Because you know strength should be more than the stress. So that strength wala force should be more than resistance force should be more than the bursting force. When you would be writing sigma CR into pi by 4 d square, that should be more than equals to tau ultimate into pi dt. So you would be getting d should be more than equals to, you would be getting t into tau ult into 4 divided by sigma CR. So mind it, this is for sheet, this is for punch. So D is more than equals to means this is the minimum value of diameter. This is the minimum diameter of hole you can produce. Tau ultimate for the punch. Here punch is going to, when you are going to apply, this is for the sheet. This tau ultimate is for the sheet. So because you know that sheet is going to fail, so there is no factor of safety for this. No factor of safety for this. But we want this to be safe. So sigma ultimate divided by factor of safety. I have done the complete derivation for you. So I feel this is more than equals to. That's why D minimum. Okay. Question number 17. Once again from the sheet metal operation. Yes. In the blanking operation, find shear to be provided. You know that punch is going to be like this. In case of shear, this is the shear provided on the punch, denoted by I. And you know the formula is shear force KT plus I is equals to F into KT. This is said to be maximum force. Apply this one, get the answer. So in the blanking operation, find the shear to be provided on the die such that the force required for blanking operation is 2/3 of the maximum force when percentage penetration is 50%. So he is saying that Fs is 2/3 of Fmax when K is 0.5. Is it correct? Solve it, solve it, solve it. Best cake design C. Gaurav Vajpayee C. Omkar is saying A. Yes, yes, yes. Rohan, quickly, quickly. Rohan is also saying C. So guys, yes, majority are correct. C is the option. So putting these value, you would be getting I to be, sorry, what we need to find out? We need to find out the maximum force and percentage penetration. Find the shear to be provided. Okay, so you would be getting I to be T by 4. C is the correct. Next question. This is once again from metrology. From inspection we have seen. This question is from metrology. Tolerance sink is the topic. This is from tolerance sink. Tolerance sink. Sir, if we remember formulas in manufacturing, then work is done. Yes. Yes, Polaki Deepak. Your work is done if you remember the formula, but yes, you must know the condition in which it is applicable. Okay, so that is necessary. Okay, so if you see this, you need to find out the dimensions of L4. So you need to find out L4 minimum first, and L4 minimum would be when L1 is minimum minus L2 maximum minus L3 maximum, and L4 maximum when L1 is maximum minus L2 is minimum minus L3 is minimum. So you would be getting L4 minimum and L4 maximum. Yes. So if L1 is 22 is this given. So L1 maximum is 21.01 and L1 minimum is 21.99. Likewise, we can decide maximum and minimum. Similarly, L2 maximum and L3 maximum can be seen. Okay, Gaurav is saying D. Omkar is saying D. Rohan, quickly. Deepak, best cake design. Omkar, okay, have done. So guys, tomorrow the session would be for machine design at 4 p.m. Do join that as well. Okay. Yes. So the answer is D for sure. You would be getting L for minimum as 1.98, 2.02. So it would be 2 plus minus. Is it clear? Yes. Let us see next question. This is from jigs and fixture. 3-to-1 principle. Three-to-one principle. Very good, Rohan. In 3-to-1 principle, the number of degrees of freedom arrested by 3 pins. So you know, when we are talking about a 3-dimensional workpiece, so initially we are going to put 3 pins. So these 3 pins, when we are going to put 3 pins on this body like this, 1 pin here, 2nd pin here, 3rd pin here. So it will be restricting these rotations and these rotations. 4 rotations and 1 translation. Okay, you cannot, once this is 1 pin, this is another pin, this is 3rd pin. Putting these 3 pins, you will be arresting this rotation clockwise and anti-clockwise. 2 rotations are arrested. You cannot rotate workpiece like this, 2 more rotations, and you cannot take it down. So 4 rotations and 1 translation are being arrested. So the answer is 4 rotation and 1 translation. You know now 3 pins are going to restrict 5 degree of freedom actually. Okay, so answer would be B. Next question is from material science, the last topic now. 3 questions from material science we have. Very good, Saikat, Rohan. Increasing temperature has the following effect on stress strain diagram. It increases ductility and toughness. It increases ductility but reduces toughness. It lower yield stress and modulus of elasticity. It increases yield strength but modulus of elasticity remains unaffected. What would be the answer? Yes, what are the temperature effects? Temperature effects. Dear, first of all, please mind it that when the temperature is increases, ductility increases, toughness increases, because the material is getting softer. And my dear, when you are going for the other properties, you know that SYT is also getting reduced. You know, when temperature is increased in hot working, yield strength reduces. So based on that, 1 and 3 are the correct one. B is the correct option. So none of you have answered it correctly. Material science is weak for you guys, I feel so. Okay, let us see question number 21. The best heat treatment process to relieve total residual stresses in the steel component is? सोच समझ के आंसर दो यार. Stress relief is associated with which of the following? If you remember the types of annealing, you know there is a type stress free annealing. So just by looking at that, you can answer. The answer is C. Annealing is used for stress relief, and the name of that annealing is stress-free annealing. Okay, the last question in front of you from crystal structure. Simple cubic, face center cubic, body center cubic, and hexagonal and diamond. These are the packing densities mentioned. Yes. Very good, guys. Rohan, Omkar. Very good. So the answer for this is A. Okay. Very good. So guys, with this we have completed the session. Tomorrow, guys, we are going to meet at 4 p.m. for machine design. So do join the session, and 2 more sessions are there. One is on Monday, other is on Wednesday. With this, my part would be over, and then Chandra sir would be coming for industrial engineering. Okay. Kiran, actually, if you see previously also GATE was having some limited number of PSUs. I feel at 2011-12 it was only having IOCL, BARC, okay, NTPC, GALE, ONGC. Very few number of PSUs were attached. Then after that, number of PSUs increased. Now some of the PSUs are taking their own exams also, but they also require the GATE syllabus. So you cannot say that opportunities are not there or scope is not there. It is there, but yes, comparatively the PSUs you can see from last year during COVID times, some seats are being reduced. But in the future we can expect it will increase once again, and once again all the PSUs would be associated with the GATE. Yes, GATE preparation helps in PSC's exams also. Okay. So goodbye guys for this session. Thanks for joining and thanks for your wonderful response. Goodbye.